Hello everybody, today we're doing word frequency. I think we've done this before, but this time we're going to dig deeper into the understanding and pushing for an interviewer about what we're trying to implement here. So here we're gonna want to implement, the interviewer would say, implement a method to find the number of occurrences of any given word in a book. A word is represented as a string, and a book is represented as an array or list of strings. And second, optimize the method to be called multiple times. The first question that I have as an interviewee is that, what do you mean by calling the method multiple times? Am I going to be calling the method on the same book or a different book? If I can call the same method on the same book, then I can offer you a better solution where I use a hash map to store the occurrences of each word, whereby I can retrieve any word when searching in O of one time because of a hash map, and sacrifice time for space because I will be using O of n space to hold these values that if there are n different types of words in this book, which is unlikely. So is that the case? An interviewer might say that that is the case, that we will be using the same book. Therefore, a class would be effective here to hold the hash map in memory. So another thing is that, suppose we're using a class, right? And we have an improper input for our book. We should return some errors, right? Because we want the user to know that it cannot be found. If the book is empty, then return 0. That's important. Another thing is, return -1. That is something that should not occur. Error. We should remember that. Now, suppose we want to have a suppose there's no item, no word, right? Should we return 0 then? Suppose the word is empty. Should we return -1? I don't think so, because if we're looking for an empty word, like empty space, we should be looking for empty space. All right? Should that be an error? I don't think so. That doesn't make any sense. What if we're looking for let's say a word that's not in a book? We found it 0 times, right? If the word's not in the book, then that's fine. We should return 0. I think that makes for a better book. So the reason why I'm able to ask all of these questions is because I'm asking why we're writing this function. Who are we writing this function for? And what are the use cases for this function? And these questions help lead us to certain edge cases that we want to take care of, how we want to implement this function. The next idea is, suppose that we're looking through a book, right? And we want people to, how do we want to deal with uppercase and lowercase characters? Suppose we have the and the, the. Are they the same word? Can they be thought of the same word? Because maybe they're used in different contexts. Maybe they have different meaning. Maybe tahi, right? Tahi means something different from the. It could be a totally different word. Do we want to account those just because they're the same sequence of characters? Do they mean the same thing? They don't necessarily mean the same thing. But how do we want the user to be able to use this function, right? In this case, suppose that the book has like these certain options here. What do you think is best for us? Like THE, is that fine? Um, they could have different meanings, like all over, because of how the book is structured. But for all we know, if we have a capital character, if that's the first character that is capitalized, should that be equal to the? And I think so. I think that is the case. But for all other cases, I don't believe that we should lowercase everything and make it a part of the book, part of the same word, because we're looking for the same word. This is not the same word. Tahi is not the. Okay, does not equal tahi. Okay, so with that, I think we are going to like just remove capitalize, remove cap on first character. I think there is a function for that. I'm gonna have to go look that up. Now, sorry, excuse me. We could also write our own function to do that by just changing the first character of our word. Okay, so I did a little research, and we have a function called capitalize, which capitalizes a word. And that way, when we store each word, it starts with a capital, and that way we reduce the chance of error. Okay, what about white space, right? Suppose there are words with white space around it, for editing reasons. Would that still be the same word as the? I would say so, yeah, it would be the same word. It would be exactly the same word. That's fine. So we remove the white space. So are there any other use cases for our user to use this function to look up a word in the book? The use case is, again, to find the number of occurrences of the word that they want to find in the book. In this case, it's the dog, and we found it twice. And I think those are all the edge cases that we want to take care of for this book. So we want to make some test cases for each of these items for our review later. And that way we can be sure that our function addresses all of these issues. So I'm going to be back with my test code, and Hello there, and we're back with a little bit more code and a test case and a class called book, which we were planning to do. And this is part of our understanding, like just setting up the code for testing later for a review. And we're gonna come with the test cases now. So same book. So if the book is empty, return -1. So let's make that test case. So what that means is that let's create a book at the beginning, and we create a book with no list, basically an empty list right now, right? And what we're gonna do is that we're gonna do a test append, and what we want, like, so suppose we're searching for bird, we want a -1 there. We don't care what happens. Whatever we search for, it's gonna return -1. We search for an empty thing, it's gonna be -1. Okay, now suppose we create a list with open word text, which we copied some text from a book from somewhere online, and we're gonna open it, read it, split it, turn it into a list, put it in our book. Right now we can search for the word bird. I don't know how many times that occurs in this, but we're gonna figure that out, and then we're gonna output that particular number of times. How we're gonna do that is control find bird. There are no birds in here, but there are bears. So, what happened there? Okay, bears. How many times? We see bear 4 times. So, what we're going to do here is we're going to say bird is going to be 0. And now we're going to search for bear, and we're going to see it for 4 times. We know for sure it exists 4 times. If an empty string, Are there any empty strings in this book? I mean, it might occur, it might not occur. There might be some weird shenanigans going on in the text. And let's say we look for that. Empty string. There is no empty string there, like just none. Okay, perfect. Let's say A, 225 A's in there. So we know for sure that A is 225. Let's put that in there and check it out. And those should return what we want to return. Now, suppose we want to make sure that we get, let's turn this off. So let's say we see something more like this "the" here. What we want to do is we want to see 4, no matter what. So I mean, just because when using control find bear or A, we see 225 either way. So that means that we have an A here. It's going to be 225 no matter what. Big or lowercase, small case. What happens if we look for the right? Is the same as tahi? Wait. We think we messed up something here. A is not 225 times, and we need to do some regex. Give me a moment, I will come back with regex. Okay, after looking at the text and how our search word text works, I see actually that it doesn't work the way we want it to, and the regex also does not work the way I want it to, because regex only works on the first character. Let me show you what I mean. So if I do a first character, if I do a starts with, and then I put an A in, right, and I do a regex, right, what happens is that it only pulls the first A from the first sentence. It doesn't pull from every character. So that's a problem. Another problem is that, we can't search for an A because one particular A, because it searches everywhere for an A. Doesn't search, so the A is no good. We have to remove that test case, and using the word text, I mean, we can totally do words like bear. We see it 3 times visually, and so let's go change that. So this is 3, and for A, we just don't know. We don't know. What we can do in the word text is add some text that we know for sure, like dog, and dog, and dog, and tahi, and I don't know how many does there are, but let's see how many dogs there are in this, so that we can get a good sense of what we're working with. So there's only 2 dogs in here. That's fine. So what we're trying to differentiate is this dog, and we don't want those dogs to be the same. This is when you have a O or something. We're talking that's what we decided on our earlier during our understanding. We only want to capitalize the DOG. So basically, DOG does not equal DOG at this point for us. Nor does it equal these other cases here. Dog only equals dog when the first letter is capitalized. And that's what we want to do. So there should be only 2 dogs in this this function here. So 3 dogs. So or we can just make them all dogs. It's all the same to us. I prefer that we just change it all to dogs. It's much easier for us than for us to think about. But for our use case, I mean, for our customer, we do want to just do the capitalization. So it's not about what's easier for us. It's about what we wanted to instantiate. So we're going to make sure that the customer gets what they want, and from this function. And we're going to look for dog, right? And it's going to only appear 3 times because we're only going to capitalize the first character, and if they're equal, then they are the same character. Okay, so with that, did we get all the edge cases? I think we did. Oh, did we remove white space? Let's do that as well. Let's remove some white space from each character. There might be some spaces in between. Like let's make sure that that is also 3. Perfect. So now we have our test cases. We have our understanding. Our match. Let's talk about our match. Right. I'm sure. So let me reiterate. So we got our white space. We got our dog for capitalization. We have our empty. We have our bear. We have our empty for bird. We have all our test cases. So sorry if you didn't see that earlier. Let me go back into the video and check it right now. Sorry about that. So I just checked the video, and it looks like I did not show the dog cases down here, which is a couple lines lower. So this is what I mean by dog earlier, if that didn't make any sense. Sorry about that. Well, getting back to the code. So here we are. We have this code. We have all this. We're ready. We're gonna match. We're gonna do a match right now. So can we see all the lines of code? Let's see how far we can go. So we can go, I think, about 75. Let's just keep it at 75 then. Okay. So with that, let's do a match. And of course, we know what we want. We want to make a hash map. Because using a hash map, we are able to store the counters, and we're able to store the number of times we see each word. Okay, so that's the plan. Let's make a plan. So create hash map to count each item as a cap word, cap the word, capitalize word, and seek for words count next time. And I think that's the plan. It seems pretty simple, the plan, but I think I'm pretty sure it works. Okay, so let's pull the plan up and let's see how we're doing. So here we see we have created this is a string. We have created a book. That's not what we want to do. We want to create a hash map. Let's do that now. So self.book does not exist yet. So we want a hash map equals to addict, right? And so for each word in book, right, we want to put that in our hash map, and of that word, if word in hash map, what we want to do, we first want to capitalize the first word, word.capitalize. So we capitalize the word, then we put it into our hash map, and if it's in our hash map, then we plus equals 1. And otherwise, we want to make that word one time. Then we can set our self.book to equal to hash map. Okay, so one thing we want to know is this function working? Does capitalize actually capitalize the word? I don't know. I don't know exactly if capitalize works. So let me test that function now, and we'll go from there. So let's not run main. Let's just make a word and capitalize it. See what happens. So let's say bird dot capitalize, and bird equals bird. Print the bird. let's see. Okay, it capitalizes. What if we have a bird equals bird, and we run capitalize on bird? Does it change it, or is it assigning? So it only assigns the word. So what we need to do is set w word equals word dot capitalize. Okay, so that solves our problem. We have created our hash map. Where's our plan? Create a hash map to count every word as capitalized. Seek the word, count next time. So we're going to seek it. So we're going to return self.book at this particular word capitalized. And that's it. So that will return a word dot capitalized for us, and we would seek it. And we'll return the count for that word. And we're done. Wow, amazing. So let's run this function, main, to see how it goes. And if we have any issues or we're solving the problem that we're intending to solve. Okay, we have bird somewhere. We have to find it. Make sure that bird has been deleted. I don't know where it is anymore. It's maybe key error, bird. So there is no bird. So first, if word, so if we have to capitalize word equals word dot capitalize, and then if word not in book, return 0, run. Okay, so we have a couple false going on here. Number 1, so we're looking for bird, and output is still it's negative, it's 0, which is not supposed to occur. So first things first, if not book return -1. Also, will that fix it? No, it will cause an error because we did not create a book. Okay, so we do need to find, so if not hash map or self.book, return -1. How's that? Maybe that will work for us. Okay, that works. Okay, now number 4, see what happens there. We were looking for a bear. We only found 1 bear. There should be 3 bears. Why is that? Why is there only one bear in this? So the problem is, I think we might have capitalized twice. So that could be it. So let's see, let's run it. So it's still 1, 3. So we counted for dog, we counted 6 times. For dog, we counted 0 times. So one thing we needed to do was strip. We needed to strip the word. So we did not do that. So we gotta strip the word, and let's run it again. Still 6 times, still 0 times. Okay, what's going on? We only see bear once. And we don't see it ever again. That's unusual. So, because we for sure see bear 1, 2, 3 times, but it looks like what happened here, there was a comma after the bear, as you can see. And that, because of the comma, it believes that we have a single word. That's an edge case that we did not think about. And so let's see what happens if we add that comma in. As you can see, this will become 2 instead of 3. So that's something that we should take care of. So we should include items with the apostrophe inside our included. So let's add that. So word with comma equals word dot plus comma. And we're going to yeah. We have a word with comma. What do we do? Should we remove the comma? Yeah, I think so. But wouldn't that generate brand new words as well? How about we search for both the word with comma and without the comma? How's that? How about with the period as well? What happens with the period, right? It's not the only thing. Oh, shoot. What's going on? So what about periods? I mean, periods, I think with any punctuation, that can occur. So that is an issue, right? So this code is getting very messy, and as you can see, there are a lot of edge cases here. So this is going to be quite a problem. So as we're trying to build this out, there will be more and more issues. So I think that we shouldn't have gone with such a tough example. As you can see, we got most of these edge cases, and now we're looking at test number 6 and test number 7 that has issues. And the issues come from spelling out dog. Like, we're looking for the dogs right now, and they're definitely hard to find. We found 6 dogs instead of 3. Why is that? 1, 2, 3, 4, 5, 6 dogs. While only the ones with capital letter should be the same dog, while everything else should be different. I'm not sure why that is occurring. That shouldn't occur, but it is. So that means we're counting all of these dogs as the same dog. So if word equals dog, that's what we're thinking. Which print hash map dog. Okay, let's see what's going on here. Whoop. Oh, it's not in there yet. Okay. So we found 6 dogs that as a capital letter and OG. So capitalize, what it actually does is it just capitalizes all dogs, which is not what we intended. And so we got to switch it up and make capitalization our own way. We did not know that the function capitalization would do that to us. And with the test, we found out. So what we're going to do is after we strip, we're going to make sure that the first word is capitalized. So that means word at 0 equals word at 0 dot capitalize. And we're going to only capitalize the first letter of the word this time. So instead, let's run it this time. Okay, so it doesn't do that. So how are we going to do this? So I'm going to go look up how to capitalize that, and we'll come back for it. Okay, so here we have a solution to that, where we uppercase the first character and we get the rest of the characters. And so we have 3 dogs now. Perfect. And lastly, we are looking at test case 7, where we have this white space, lots of white space. Let's see what we're searching for when we strip it, right? All right, let's take a look at this word. I think it looks better if we change this code like so. Of course, there are other things that we could change, but we don't have time for that right now. We're just going to make this a little bit more suitable for just our test cases now. And we'll come back and update this in the future when we when we see more errors. And I can predict a few errors already with exclamation marks and other types of punctuation that would need to be dealt with. But yeah, so maybe we can make a note of that. Like not all punctuation has been taken care of. Think. Okay, so we're gonna leave that for later. And our when we look at our last case with the dog, what is the error here? We don't know. That's the specific case I want to see actually. What's actually going on? What are we searching for when we're looking for this word? Are we looking for dog? So we're printing the word, right? -1 equals 3, so that's false. What are we printing? Oh, forgot. Sorry, my bad. Here's the book. Run, please. So we have dog. We see 1, 2, 3. We're looking for dog. Okay, what happened? Why is it not capitalized? Okay, so we need to strip the word, and we need to run this function here for this. Let's run it again, and we have true. Perfect. So we have taken care of all our cases now, and we have everything functioning. That means we have done our review. We have checked all our edge cases, and right. So if not word, then return 0. I think that's one thing we need to do. Okay, so with that, we are complete at this point with this this code for now. And if not word, let's return -1 as well. I think that's better. I mean, that's something that we changed. Yeah. So that looks good to me at this point. And as a evaluation, let's take a look at that. So in terms of evaluation, right? we have O of n time to create, but a O of 1 lookup time. And also a O of n space complexity for holding the dictionary hash map. So with that, we have thoroughly gone through this problem to solve this during an interview. And I'm much more proud of this solution than the previous solution that I provided earlier, because I did not go through the interview process as thoroughly as I could have. I hope with this video you found more information, although it's much longer. I think I would create a new name for this. I would call it interview. So like mock interview series, and hopefully you also find this enjoyable. If you like this content, please like and subscribe, and make a comment so that way I know that this is the type of content that you would like to see more of. All right, with that, I will see you in the next one. Thank you. Bye.